students, and welcome to another video lecture on logic design. In this video, I will teach you the rules and laws of Boolean algebra. I feel that this is a challenging topic to teach via a video lecture, but I will do my best. So what is Boolean algebra? Boolean algebra is a system of mathematical logic. It is governed by a set of well-defined rules and laws. There are a set of elements, which is basically 0 and 1, and it also has a set of operators, which is or, and not. We use capital letters in Boolean algebra to denote variables, and these variables are in turn used to represent logic functions. Values of the variables and logic functions can again be either 0 or 1. An important thing to remember here is that all variables and logic functions have a logical significance only and not a numerical significance. Any logic function or functional relationship in Boolean algebra can be proved by a method called as perfect induction, which is nothing but a truth table. Let us now look at some axioms or postulates of Boolean algebra. These are nothing but a set of logical expressions that we accept without proof and upon which we can build useful theorems. These axioms are based on the definitions of the three basic logic operations we have already discussed: and, or, and not. The and axioms are 0.0 is equal to 0, 0.1 is equal to 0, 1.0 is also equal to 0, and 1.1 is equal to 1. The or axioms are 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0 is equal to 1, and 1 plus 1 is equal to 1. The complement axioms are 1's complement is basically 0 and 0's complement is basically 1. You can also read it as 1 dash is equal to 0 and 0 dash is equal to 1. Now based on these axioms, we have some laws. The and laws state that if a dot 0 is equal to 0, that is, anything ANDed with 0 is a 0. Similarly, a dot 1 is equal to a. That is, anything ANDed with 1 is a itself. A dot a is equal to a. That is, a ANDed with itself is a. And similarly, a dot a dash is equal to 0. That is, a ANDed with its complement gives you 0. In the same way, we have OR laws. A plus 0 is equal to a. That is, a ORed with 0 is a itself. A plus 1 is equal to 1. Anything ORed with 1 is 1. A plus a is equal to a. A, when ORed with itself, gives you a itself. A plus a dash is equal to 1. That is, anything ORed with its complement gives you 1. Now you all will be familiar with these laws. The commutative law, which states that a plus b is equal to b plus a. This can be extended to any number of variables. So a plus b plus c is equal to c plus b plus a. Another form of commutative law is a dot b is equal to b dot a, which can also be extended to any number of variables. That is, a dot b dot c is equal to c dot b dot a. Another set of laws that you're familiar with and which can be applied to Boolean algebra is the associative law, where a plus b plus c can be written as a plus b plus c. Similarly, These laws are self-explanatory, and of course, this law can also be extended to any number of variables. Another set of laws that you're familiar with and which can be applied to Boolean algebra is the distributive law. The first distributive law states that A into B plus C can be written as AB plus AC. The second distributive law you will use extensively while solving problems is A plus BC, which can be written as A plus B into A plus C. On the same lines, the third distributive law states that A plus A dash B is equal to A plus B. The next set of laws is called as the absorption laws. You have two laws here. A plus AB is equal to A and A into A plus B is equal to A. Now some of these laws have been given additional names. For example, we have the negation law, which says that A dot A dash is equal to 0. Second, A plus A dash is equal to 1. There is also a law called as the double negation law, which reads A double dash is equal to A. In the same way, we have the identity laws. A dot 1 is equal to A and A plus 1 is equal to 1. The null laws say that A dot 0 is equal to 0 and A plus 0 is equal to A. You also have the idempotence law, which says A dot A is equal to A and A plus A is equal to A. You are expected to remember each of these laws, as you will use these laws for solving Boolean expressions. Now remember that from the initial introduction to Boolean algebra, I mentioned the term proof of induction. This means that any logic equation or logic function can be written in Boolean algebra and can be proved using this method. In other words, we make use of a truth table. So in this slide, I will explain this method using a single example. And using the same technique, you can apply it to any logical equation. I will use the terms logical equation or logic equation or Boolean equation or Boolean expression interchangeably. So as my example, I will take the second distributive law, A plus BC is equal to A plus B dot A plus C, and prove this using proof of induction. Let us start with the LHS, which is equal to A plus BC. Obviously, here you can see three variables A, B and C. These basically become the inputs to your equation. Now, I will write the binary sequence using 3 bits, starting with 0, 0, 0 and ending with 1, 1, 1. Now, in the LHS, you can see a product term called as BC. For this, we take the logical AND of the column B and C, and we get this. Next, to complete the LHS, we have to take the logical OR of A and BC. Therefore, A plus BC will give you another column which reads like this. So this is the result of the LHS. In the same way, let us do the same thing for the RHS, which is equal to A plus B dot A plus C. Again notice that the RHS contains 3 variables A, B and C. We put in the bit representations for 3 variables. Now from the RHS we get one term, that is A plus B. For this, we need to find the logical OR of the columns A and B. So doing this, we get, similarly, we have yet another term in the RHS which reads as A plus C. For this, you need to find the logical OR of A and C. And we get, now we only need the logical AND of A plus B and A plus C. So doing this, we get, hence you can clearly see that the LHS is equal to the RHS. This method is called proof of induction and can be applied to any Boolean expression having any number of input variables. Let us look at another method to prove the validity of logical equations. This method uses Boolean algebraic axioms and laws. So given any logic expression, we can apply the axioms and laws studied earlier in this video to prove it true. Let us take the same example. A plus BC is equal to A plus B dot A plus C. To start solving this equation, let us start with the RHS. Let us open the bracket out so that you can get this. I will rewrite the same equation as follows. Clearly notice that A dot A is replaced with A and B dot A is written as A dot B. This can be done because of the following laws. The idempotence law states that A dot A is equal to A. And the law of commutativity says that B dot A can be written as A dot B. Now I will simplify this equation further by pulling out A as common. This is what I get. I rewrite this equation as, this is done because 1 plus C is equal to 1, following the identity law. Simplifying this equation further, we get, and here this is done because 1 plus B is equal to 1, using the same law, that is the identity law. Also, since A dot 1 is equal to A, using the identity law, I can rewrite this equation as A plus BC. This is nothing but equal to the LHS. Thus, you have proved that the LHS is equal to the RHS. In this way, you can prove all the laws of Boolean algebra. Refer to your textbook for additional examples. That's all for now. Stay tuned to the classroom for more videos.